my lecture. Actually, a couple of you guys emailed me that you cannot come to this lab today. So I decided to have a online lecture, live online lecture, so that I can record, right? I can record my lecture. So later on, you guys can. I'm gonna upload this video lecture, right? And later on, if you want to listen to my video lecture, you can, watch this video multiple times, right? Good thing about this, having this my lecture recorded, is that later on you can watch this multiple times if you want to. Okay. So having said that, and then also, actually my TA is supposed to give you a lecture, right? It's supposed to have a lab on a dynamic NAT, dynamic network address translation. But I decided to pretty much cover the half of this labs sections because I give you the basic concept of dynamic NAT, dynamic network address translation. And then my TA can focus on the packet tracer part, so actual implementation part. Okay, so today's lab is basically have two parts. The first part is basically intro to concept of dynamic net, which is very important. There are a couple of things that I like to teach you, right, about a dynamic net address translation. And then, yes, so that's a part one. And part two is basically the Cisco lab, right? After you listen to the first half, right, then you can focus on the implementation part. And my TA will take over. Okay? So first, let's talk about, first, please, from the class website and download, right? Download this the slide, lecture slide, right? And you know what? I think another thing that I can, let's see. Hold on, it's okay. I don't know if I can invite you. You know what? Hold on. I think another way it is you can actually turn on your lab computer, right? So let's just do that. You can turn on your lab computer. Right now, I'm going to send you the Zoom link so that you don't have to really. Actually, you can log into your lab computer or your laptop, and then you can watch my lecture through either your laptop computer or the lab computer. So let's see. Hold on. No, not the Gmail. Okay, hold on. Okay, hold on. Sent. Let's see the course tools. Right now I'm about to send you an email. Send an email. So let me see. I'm going to show you the email. So all users, and then I think I'm going to call Zoom link. So you can click this Zoom link. So the paste, Control V, right? Control V. Okay, so this is a Zoom link. You can click this Zoom link or like cut and paste and then put it into the browser. Then I think you can, if you already have a Zoom installed, you can also watch this video tutorial through your laptop or school computer. I think school computer has a Zoom already installed, your lab computer. Just test. So I'll just, all users, right? I'm going to send to this Zoom link. Okay. So by now, I think you probably received this Zoom link. But anyway, so let's just talk about NAT, network address translation. And first, before I talk about this network address translation, what I'm going so you know that we have a class A, B, and C, and D, and E, right? Hold on. Okay. So we have a class A, B, and C, and D. Right. And oops. Okay. So we have a class A and B and C. So let me just zoom in. And then focus. Okay. So this is a class A and class B, class C, right? And we know that class A is /8. That means 255.0.0.0. And then for the class B, it's a 16, so 25.25.0.0, right? And then /24, that's for the class C. So we have 255.255.255.0, right? And for the dynamic NAT, there is a new concept called wildcard mask, which is the exact opposite of subnet mask, right? So for example, if the subnet mask is /8, which is 255.0.0.0, your wildcard mask is convert this 255 to 0, and then 0 to what? 255. So basically 0, 255, 255, 255 for the class A. And for the class B, right? For the class B, this 255 it's become, you have to make this to 0 and 0, right? And 0 is what? 255, and then this is 255, right? So it's going to be 0, 0, 255, 255. The class is, this becomes this, you make this 0, 0, 0, and 255. Anyway, so as you can see, the wildcard mask is the exact opposite of subnet mask. Okay, so in a minute I'll explain how this wildcard mask is used. Okay, so this is the new concept number 1, which is new to probably you guys. And this is another difference between the static NAT and dynamic NAT. Okay, so let's do a couple of exercise. So we have, let's say we have this IP address, right? And then in the local area network LAN, we have, let's say we have this private IP address. So unregistered means a private IP address. So we have what? 192.168.10.2, right? And then we have 10.3 and 10.4, right? So in the local area network, we have 3 machines with this IP address. Okay, so we know that this is a class C, first of all, and actually the class C, and it's a private IP address. And then we know that it's class C, that you automatically we know that this is subnet mask, right? Which is /24, right? And then the wildcard mask is the exact opposite. So 0, 0, 0, and then 255, right? So that's a wildcard mask is exact opposite of subnet mask. Now we have public IP address. Let's say 3 public IP address. And then by looking at the first octet, we know that this is class C, and therefore we know that this is what? We know that this is the for the class C, this is subnet mask, right? And this is wildcard mask, same thing, right? So this is okay. So another example, and then we have what? Another example is we have I'm focused, sorry. So we have oops. Okay, so we have what we have. This is given IP address. So by looking at the first octet, we know that this is what? Class A, right? So that means subnet mask is what? 255.0.0.0, right? This is subnet mask. And wildcard mask is the exact opposite, right? Wildcard mask is 0 dot, right? 255.255.255, right? So that's the wildcard mask for this class A P address. So I want you to do the B and C on your own. By the way, okay? Okay, so that's a wildcard mask. Now, so let's just do another example. So this is what? The IP address is 192.168.10.0, right? So that's a class C. Therefore, the default subnet mask is 255.255.255.0, which is this is a class C default subnet mask. So what is the class of the above IP address? It's a class C. What is the network portion of the IP address? Okay, so that means like, in other words, what is a network address, right? So the best way to solve this problem is draw IP table. So if you look at the answer, the next page really shows the answer. The best way is you basically draw the IP table like this. So let me just draw the IP table. And 192.168.10.0, right? So let me just draw the IP table. So let's see. 192.168 dot, right? 10.0, right? Okay, since this is a class C, so last octet is the one that basically since it's a class C, the last octet, the fourth octet is the one that it's kind of you have to really focus on. So I'll just extend this instead of a 0. This how many bits? 4 bits, right? So that's basically the binary, 8 bits, right? So basically in decimal form, basically this is 0. So this is, we have 192.168.10.0, right? And then the subnet mask, since it's class B, the subnet mask is 255.255.255. Okay, 0 means basically I'm going to expand and then expand this, and then I show this 0 in bit. So 1, 2, 3, 4, 5, 6, 7, 8, right? So basically in decimal 0, right, it's the same as in binary bits is 8 bits, right? So 8 of them. 1, 2, 3, 4, 5, 6, 7, 8, right? 8 of them. So this is 8 bits. Okay. And so to find a network portion, right? So you always draw the line where that, okay, by the way, so 255, right? If I just convert this into a binary form, this is like 1, 2, 3, 4, 1, 2, 3, 4, dot. 1, 2, 3, 4, 1, 2, 3, 4, 255, 255 dot, 1, 1, 1, 1, 1, 1, 1, right? Dot, 0, 0, 0. So that's a subnet mask, right? So you always draw the line where the 1 ends, right? So I'm going to draw the line here, right? I'm going to draw the line. And the first IP address is basically the network address. So 192.168.10 dot, right? 0, 0, 0, 0, 0, 0, 0, 0. So this is what? 192.168.10.0, right? So this is the very first IP address. So basically this is what? This is a network address. This is a network address. So as you and then you know that this is the left side is always what? Network portion. And then your right side is always what? Host portion. Okay, so this is network portions and this is host portion. The next IP address is what? 192.168.10.00000001, right? Which is 192.168.10.1, right? So this is what? This is the first usable host IP address. And then the next usable host IP address is 192.168.10.00000010, which is what? 192.168.10.2, right? And so this is what? The second host IP address. Okay, so just keep going, right? The last one is 192.168.10. What? 1111 right? So which is what? 255, right? So 192.168.10.255 is last IP address. So usually last IP address is reserved for the broadcast. So this is the broadcast IP address. Okay. Now, so let's think about the wildcard mask. You know the wildcard mask is exact opposite of subnet mask, right? So the wildcard mask, I mean, so you know the thing is, subnet mask is kind of emphasized by putting 1s, right? It really shows that this is your network portions. This is your network portions and this is your host portion. Whereas the wildcard mask, so this is wildcard mask, right? The wildcard mask, it's the opposite of 255 is 0, right? The opposite of 255 is 0. And opposite of 255 is 0, right? And then this is a 0, right? So basically 255. So if I just change into the binary form, the 0 it's 1, 2, 3, 4, 5, 6, 7, 8 dot 1, 2, 3, 4, 5, 6, 7, 8 dot 1, 2, 3, 4, 5, 6, 7, 8. So because each octet is basically 8-bit long, right? And 255 is what? Yeah, 255 it's basically what? 1, 1, 1, 1, 1, 1, 1, 1, right? So this is a wildcard mask. As you can see, the wildcard mask, it's kind of emphasizing the host position by putting all ones in the host positions, right? Whereas subnet mask by putting all the ones in the network positions, right? So this is a wildcard mask. Okay. Having said that, see the 0000255 is a wildcard mask for this particular problems, right? Basically, this diagram, right? This diagram is same as this. Okay. By the way, I'm going to upload this video lecture, right? So if you're not sure, then you can always watch my video tutorial multiple times, right? Okay. So basically, this is same as this. Okay. The same thing. This is another example, another practice questions. Now 210.210.210.0, and this is your subnet mask. So basically the same thing. So I'm gonna skip this. So basically, if I just look at the answer, this is the subnet mask, right? So this is subnet mask, and there's where the ones ends. So I'm going to draw this line, right? And I know that this is what? This is network portions. And then this is what? Host portions. And so the network address is 210.210.210.0. Since this is your first IP address in the IP table. The first IP address is, that is always reserved for the network address. And this is the last one. Last one is always reserved for what? Broadcast IP address, right? So basically, if I just draw the diagram, and so this is like, for example, if this is local area network, this is the LAN, right? Let's say if this is the LAN, right? If this is the LAN, since your network address, the network address is what? The address for the LAN, local area network, or the, right? So this IP address for this cloud is what? 210.210.210.0, which is the net. That's why I call it network address. It's not an address for a specific host. It's rather it's the address for the network, right? And then you have the first host IP address is 1, right? So let's say if there is a switch, and then there is a PC, right? Workstations. And this PC's IP address is the first one could be, let's say, 210.210.210.1, right? But typically, okay, this is not always, but they use the second IP address. Now, what about the first usable host IP address? The host IP address is typically, it's not a standard, but a lot of system admin, they use first host IP address for the gateway router. So for example, there is a gateway router, right? And then this gateway router has this interface, fast Ethernet interface. And they assign this first host address to this node, to this interface. So this is a gateway router. Right, this is gateway router, and usually the system admin assigns this first usable host IP address to this node. So this is 210.210.210.1, which is this guy. And of course, a third usable host IP address is the 3. So this is probably 210.210.210.3 and etc. Okay. So this is the network address. And then, of course, wildcard mask. By the way, wildcard mask for this is opposite of subnet mask. So it's a class C. And so the wildcard mask is 000.255. Okay. Now, the next. So now, let's talk about, now I think you guys are ready, right? You guys have all the background. Now it's time to talk about the dynamic net. It's called many-to-many. So basically the idea is this. Idea is, let's see. Okay, so let me just read a couple of important points. The dynamic net is called many-to-many. And a multitude of hosts with a private IP address can share equal or fewer amount of public IP address. Basically what that means is, let's say this is your inside network, right? And then you have the outside network. So inside you have a list of private IP address, right? And then for the outside, you have a public IP address. And so basically the net means the private IP address has to translate to the public IP address, right? And then there's another private IP address has to be translated into what? The public IP address. Or sometimes this private IP address can be translated into the same public IP address. So this is translation. So this arrow means translation. So in a sense, that is what? It's a many-to-many translation. So it's a many-to-many. So that's why it's called many-to-many. And you know the static, right? Static IP address is always what? One-to-one. But okay, so let's just draw one more time. And then this private IP address can map to the same public IP address. So in a sense that this is what? M2M. That's for the dynamic net. But for the static net, it's really one-to-one, right? One private IP address translated into one specific public IP address, the vice versa. So this is called what? One-to-one mapping. And whereas the dynamic net is many-to-many. It's many-to-many mapping. Okay. So, and you know that it's when it's translated, you can apply something called hold on. You can apply something called access control list. So you can control. So you can actually apply access control list here. So that's the next slide. And it has what? It has standard access control list. And also there's two different kinds of access control list. One is the standard and another one is what? Extended. And for today's lecture, we're not going to talk about extended access control list. We'll probably talk about this later. Today, let's just focus on the standard access list. And usually for the access control list, they use a number, right? The number is ranging from 1 to 99. And then you know that it's allow you to permit, so this is important, permit or deny traffic from a specific IP address. So it's kind of control the source IP address. Whether you're going to deny or permit a traffic from specific source IP address, right? So for example, by applying to the access control list, you can allow, right? You can allow, or you can deny. Okay, that's a concept of access control list. Depends on what? Depends on the source IP address. Depends on the specific IP addresses. So that's the idea of the access control list. Okay, next. So basically, just like I said, the main difference between the static and dynamic is the static is what? One-to-one, and dynamic is many-to-many. I think that this is probably most, important difference, right? And then when you use a dynamic NAT, you know that we can apply the access control list, okay? And then it use wildcard mask. And then I'll talk about this pool of public address in a minute. We know that it's many-to-many, right? So I'm going to explain the dynamic NAT configuration, dynamic NAT using an example. Okay. And by the way, before I show you an example, okay, example like this one. Let me first introduce a couple of important terminology. Okay, I want you to focus on the following. I want you to know the following term that used by NAT. First, it's called inside local. So let me just highlight a couple of keywords. There's inside local means the source host IP address inside. So this is source host inside address. Okay, before translation. So idea is, okay, and then outside local. So this is inside local, right? And outside local means address of an outside host as it appears to the inside network. So this is the important thing is address of what? Outside host, as it appears to the inside network. And inside global, right, it's what? Source host address used after translation. So this is important. After translation to get onto the internet. And outside local means what? Address of outside destination host. Okay. So I want you to kind of know this term. Okay. And then instead of explain this terms, right, using this diagram, I'm going to use following diagram to explain these four different terms, okay? Inside local, outside local, inside global, and outside global, okay? Let me just take a break. Let me just take a 5-minute break before I talk about this diagram and then apply this terminology. I'm going to apply this terminology to this diagram, right? So let's just take a 5-minute break. A couple of minutes, 5-minute break. And let me just have a cup of water. So I'm going to stop recording my